we're going to write some very simple USD files. And we're going to do this directly writing code in USD format. The reason we're going to do this as opposed to laying down Houdini nodes and just kicking stuff out is because it's really useful at the beginning stages here to understand what's happening in USD. It will clear up a lot of problems later on, and it will help you diagnose issues that you might run into with your files. So the first thing we want to do is make sure that we are in a Solaris desktop here. So I'm going to click Solaris. And for now, I'm going to make sure that we're in our stage context. And you'll notice that when I'm in the stage context here, one thing that happens is our geometry spreadsheet has changed to a scene graph. And we have a bunch of different options here in our viewer panels. So we can actually initialize renders in the viewport here through Solaris, which is great. So if I press tab, you'll see there are a ton of different options that we have here that aren't available to us in standard SOPs. But for now, what we'll do is we'll put down an inline USD. Now, I want to comment really quickly to tell you that you will almost never use this in actual production. We're using this right now just to demonstrate pure USD writing and what's happening in our files. So don't worry, we're not going to need to write any code here. We're actually just going to use the drop-down menu and auto-generate the code for us. So let's take a look at what's happened for us. We've written a few lines of code, and all of a sudden a cube popped up in our viewport, and our scene graph here has been populated by some primitives. Now, looking at the scene graph, what we'll see is a hierarchy here. And if you look closely, you'll notice that this hierarchy is very reflective of what happens here. So on a top level, we've defined something called a transform, labeled geo. Here we have a transform object with the name geo. And inside that block of code, we have another block of code where we've defined a cube primitive labeled cube right here. And we set the size of that cube. So if I select the cube, we can scroll down in the properties and we can see that its size has been set to 1. I can change that size to 2, and you'll see the cube changes and the size property changes in there. So very simply, that creates USD. This is it. This is a very basic USD file. Now, at this point, we could write this out to disk and we could read it back in, and from there we can do whatever it is that we want with it. So taking a look at this, you'll see that you can change anything you want. So if I wanted to change the name of this and call this my cube, you'll see now that cube is labeled my cube. And that's kind of the basics of like how this works. It's very simple file structure. And you can see that the file structure represents a hierarchy of data, and you define things. We'll take a look at a bit more complicated examples, but for now, let's start with this. Let's start with my cube, or just cube. Give it a lowercase c. And now what we'll do is, instead of making a cube, let's go and make a sphere. So I just copy pasted that, and instead of a cube primitive, we will define a sphere primitive. And we'll label this sphere, and spheres don't use the size property, they use the radius property. So now we have a sphere. I can see the radius is defined here. It's a radius of 1. Again, we can change that. Or go back just like that. And that is, again, basics of what's happening. Now, we'll go ahead and cache these out. And what I want to do for our purposes here is I want to demo something. So I'm going to call that cube. So it has the same name. You'll notice it has the same name. It has the same path, right? So we're going our root, then geo, then cube. If I go over here, same thing. We have root, geo, cube. And I'm going to write each of these out to disk. So to do that, we use a USD ROP. If I select the USD ROP, I can change our output file. So we'll go into here and I'm going to make a USD folder. And this will be cube.usd. I'm going to do this as USDA. I want this to be ASCII format so that we can read it. Typically, when you're writing geometry, you would not do it in ASCII, but this is a very simple file. And this is so that we can open it up in a code viewer if we want later. So we'll save that to disk. I'm going to do the same thing here, but I'll do this with our sphere. All right, so we've just written USD files to disk. So to bring this in, I'm going to sublayer. And what I'm going to do is we will sublayer our cube here. And you'll notice that brings our cube back in. If I want to read the file, actually take a look at what we wrote in that sublayer, I can go to my scene graph layers. I can make sure that this is on here. I can go find what we've brought in here, and we can see that it essentially is exactly what was up here in our inline USD, but it adds a couple pieces of metadata up at the top of the file here. That metadata is in here. It's some of the options that you can find here in layered metadata. There's a whole bunch of options that you can put in here, and you can also do things to configure the layer when you write it out, but we'll get into some of that stuff later. But basically, you can see we've got the exact same file that we wrote out here. Now what I want to do is grab another sublayer, and I am going to grab our sphere. All right, so it's exactly like we thought. We're going to get the same thing. If I go back to my scene graph layers and I select that, you'll see we have exactly what we wrote before. Now I'm going to do something interesting. I'm going to take my cube as a base, and I am going to layer my sphere on top of it. Now, notice what happened here. The cube changed into a sphere. It basically layered the data on top. If I go to my scene graph layers here, what we'll see are we now have two layers. We have a layer that says, okay, this geometry starts out like this, and then we have a layer above that says now we have actually overwritten what's happening here. And I can mute those layers in the viewport. So this is one of the basic premises of USD, is that we can layer changes on top of each other. And that way it becomes non-destructive. So, we'll say one department starts like this, they're doing, something with this object. We've made some changes, we bring it in and we layer on top of it. So one thing I will point out is if we go into our code here, one thing that we wouldn't typically do is redefine some of these things. We would call them overs, so they're overrides. So there's a little bit of structural difference here, but we'll get into that when we get more into layering and how all of this stuff works. For now, this is just a very basic demonstration of how this system would work. So we essentially just build up layers on top of each other, and that is kind of the basic idea of USD, is that one person can be doing one thing, another person can be doing another thing, and then we combine them almost like Photoshop layers, and eventually we get a final composed scene graph that says, okay, this is the final results of everybody's work. Let's go ahead and render this out. Now, what we just did was a very, very simple example of what USD is and how it works, but let's take a look at something that's a little more relevant to production just in terms of the workflow. So typically what would happen is an artist would do something on an asset or on a stage, whatever it is. They've done animation, they've built something, and now they're ready to pass it off to another artist or another department. So the other department would bring in that object, that data, the animation, whatever it is, and they would do it most likely through a sublayer. Kind of depends where you are in the department. Sometimes you're referencing things in, but let's just, for our sake of demonstration here, call it a sublayer. And now somebody else needs to act on that data. So let's say we got this cube here, and now let's make some changes, right? We're going to transform. I'm going to grab the geo here and just throw that into the primitive that we're going to transform. And we're going to, make a change, move it like this. And then we are going to turn it into a sphere, right? And that's it. So we've made these changes, and now we're going to write that out to disk. Let's write that out and see what we get. So we should get the same thing. I'm going to reload the file, and let's take a look at what we got here. So looking at the file that was written to disk, what we see is something that we didn't have before. We have a reference to a sublayer. So what this is saying is this file should go find the file that's a relative path to us called cube USDA. So start off by importing this file here and then do these changes. Now this is new to us as well. You'll see that we have written out the transformation data into our transform. Okay, so it gives us a transformation matrix, transform order, and then we have redefined the primitive that was cube into a sphere and given it some additional properties here. All right, so that is what has happened here. Now, there are a couple things that are interesting and probably are not the way that we would want to work if this was meant as an override and not the final product of our composition here. So if this was our endpoint, we'd be fine. But let's say, again, that this had to pass off to, again, another department, or we only were interested in writing the sparse data. What we would want to do here is actually remove this reference and keep everything else that's in here so that it's very sparse. The other thing that we would want to do is we don't need to redefine this transform because it already exists on our geometry, and we don't need to redefine this primitive because it already exists, but we do need to override what was happening in the primitive. So let's go back to our inline USD here. Here we would change our defs to be overs. Now, what you'll notice is nothing has changed in the viewport. If I disconnect that, it does change. You'll notice these icons have changed and nothing happens. So what happens with an over instead of a def is an over says I can't exist unless the data coming in is already there. I'm meant only as an override. And it's meant to, again, be performant. So that's coming in. The other thing that we would want to do is remove the reference to the sublayer. The way that we do that is by starting a new layer with a layer break here. So what this does is it says when I write out this file here, I only want to know about these things. I don't want to know about anything that exists above here. I want to make a very, very sparse file. So again, we're overriding. Now I'm going to write out this sphere USDA. So we'll save that to disk and we'll take a look. Now I'm going to reload the file. You'll notice we have nothing in the viewport and we've gone to these icons here. Let's take a look at our layers here. Now when I scroll up, you'll see that reference to the sublayer, it doesn't exist in our metadata anymore. That's because the USD file that we wrote out doesn't know about this, right? What we've said is ignore anything that came before here. Only give me this information here. between the layer break and my ROP. So what we've written to disk are just our overrides for the transform and the override for the geometry. Now, because this exists as an override, it is dependent on the data coming in above it. So if I connect our two stages now, we see that our changes have worked. We've done our transform and we have changed the geometry. If I write this out as a piece of a USD as well, let's go ahead and grab our final. You didn't have that before, but I had that. I'm going to overwrite that, save that to disk, and now let's sublayer our final in. And our final now is the complete composed scene graph. So we've transformed the sphere and our scene graph looks exactly like it should look. Let's take a look at what that file actually looks like. Now you'll notice that final file is very, very sparse. It basically has some metadata and that's about it. So what it's telling us is exactly what we see in the graph here. We read it from bottom to top in terms of layer order. It says reference in the USD for the cube. Now reference in the USD for the sphere and stack the layers up like this, and that becomes our final composed scene graph. Now the interesting thing about this, because they are layers, is we can always take a look at the layered stack and we can mute those changes. Now this is just for the viewer, but it gives you an idea of how your scene graph is composed. So think about it like a folder. You know, this is our final, and then inside our final, we have these layers that build up to create this. And these can be nested. You'll see very deep layer nests in complex projects. But this gives you a better sense of how the system as a whole works and how layering itself works in a very, very simple example.